So I'm already here. I've got German suites ready, which I can't share with you, unfortunately, but hopefully next year. I've got Lego prepared, so it'll be fun. So what we'll talk about is a masterclass. So I'm planning to do a series of these kind of lectures where we go into some advanced topics, because there are lots of topics or lots of help out there for beginners. There are training courses and step-by-step tutorials and really quite a bit of stuff out there. And there's also a fair bit for advanced users. But for those users who really want to take it one step further and go all in and very deep, there's very little, in my opinion. So I'm planning to do a series of masterclasses, and this will be the first one where we start discussing several topics. And later on in future sessions, we will deep dive into each one of those. But this is also useful for absolute beginners, because you will learn about some concepts and philosophies and approaches that you should get right from the start. So you should definitely stay here with us. So let me introduce myself. My name is Ben, and I've been doing AnyLogic modeling for over 12 years now. Started all the way back in 2009 in Southampton in the UK, doing a PhD in aerospace engineering. And I've used AnyLogic ever since. So I did a rough calculation. I think I'm well above the 10,000 hour rule of using it. After my PhD, I joined Decision Lab in the UK doing simulation consulting work for defense clients, aerospace clients. And Decision Lab is also at this conference. They also present, so do check those guys out. And then I joined McKinsey to bring simulations to management consulting, because I thought this is the perfect consulting tool, actually. It's not just for analysis, but it's also for communication, for thinking right and understanding systems. So I've been with them full-time for 1.5 years, and I've also since then been what's called an external advisor. So I keep working with them and doing studies with their clients. But since 2018, I've got my own company and now working with various clients like McKinsey, like Goldward Research Labs, which you'll also see in this conference, doing simulation work. Good. That's a little bit about myself. Now, we have 60 minutes or a little bit less, 55 now, and I want to cover 4 topics with you. So I've got a list of topics lined up for this masterclass, but we won't go into each one of those today. We'll go into 4 of them, the 4 white ones. The gold ones are for future stuff. Now we'll start by talking about what I call purpose, model purpose. Sounds very loose, but it is actually the most important topic. So that's why I put that at the start, and we'll see why that is the most important topic. We'll talk about modeling approach. So how should you actually think about modeling? What kind of process should you be following? And it's a very simple 2-phase approach that we will explore. We'll talk about model structure. How should you actually structure your model? We'll talk about inheritance and embedding agents and object-oriented processing. So it's a bit more technical there. And at the end, I think lots of people are going to be interested in collaborating, because simulation is gaining traction. It's being used more and more. Big companies, bigger models, more and more people working on one model together. So collaborating is getting very, very important. And we will focus on collaborating via GitHub, because that is the industry standard these days. So we'll see some concepts and best practices there. But let's take a break and let's look at some pictures, because I've talked a lot. So what better picture to look at than an aircraft? Remember, I'm an aerospace engineer at heart. And even better, it's an aircraft with myself in front of it. So we'll now go into the purpose of modeling. Now, why am I showing this picture? First of all, it's about to tell you that I'm learning to fly, which is a lot of fun. I've done my first flight solo, meaning I've landed this thing all by myself without anybody in the cockpit, which was very cool. But I had a good flight lesson the other day with the flight instructor next to me. And he said, Ben, can you close your eyes while we were flying? It's like, okay, I'm sure you've got something. You have control. I will close my eyes. And he let me sit there for 5 seconds or a couple of more seconds. And then he said, Ben, are we still flying straight, or have you noticed something? Are we maybe in a curve, or are we going up? Are we going down? And I didn't feel anything, felt completely normal. So I thought, well, I think we're still flying straight. And I kept my eyes closed and said, yeah, okay, let's keep them closed. Feel if you feel anything, say if you feel anything. And a couple of seconds later, he was asking again, and it's like, still pretty straight to me. So he said, okay, open your eyes. I opened my eyes, and we were basically in a very, very steep bank looking to the ground. We were high enough up, but it was very scary. I had to remedy the situation. Now, the thing with aircraft is if you just steer them very slowly and then just let go and sort of do something else, check your charts or whatever, look into some documents, the aircraft will actually continue to bank further and further, and you don't notice it because it's very slow. And if you then look up, you're in that predicament. It's like, oh my God, what's happened? And you don't feel it. And it's very similar in simulation modeling when you work with clients, because you start out with a simple project and then they say, Ben, can you add maybe this feature as well? That'd be very cool. And so, yeah, sure. It's not too much to ask. And then another feature, and they ask again, and so on. So things can get out of control very quickly in simulation modeling if you don't focus on your model purpose. That's why we talk about it. Let me tell you another story. So I was working on a gold mine model. So I was asked to create a gold mine, digital twin. The purpose that we agreed on upfront was to quantify and predict bottlenecks that will happen in the next 3 months. So I sit down, build the model, very nice. It worked quite well. People were very happy. So they came back and said, this is really cool. Can we also use it for our weekly planning to predict what will happen next week? And to them, that was the natural next step. But to me, that was a huge change in purpose. So I had to step on the brake, say, whoa, 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 that's a big one. This is going to need a lot of changes to the model. We need to be much more detailed and do a lot more testing. So we did that, and we invested another 3 months of our time to actually come up with that tool. And now we had a super detailed digital twin that could actually be used operationally, which is when they came back and said, our CEO has seen that and really likes it, and he would like to use it in his board meetings to discuss things with his board members and test out simple experiments and tell stories. And it's like, great, but that's an entirely different purpose again, and we really can't use this huge, big, fat, complex model for that. It would be overkill. It's much better to build a new simple model. So purpose is very important, and you need to stay on top of your model purpose. So let's explore what purpose actually is. It's story time. It is a story, a very, very brief story about what problem does your model solve. So what? It should not be more than 1 or 2 problems that a model typically solves. So you really need to narrow things down. If your client says, I want a model that does predictions, that can be used for strategic decision making, and will tell me what happens tomorrow afternoon, that is not a model purpose. That is a recipe for disaster. So do not go there. So you have to be really specific. What is the problem that we're solving? And go further. Who will solve it? How will this person solve it? You can even ask, where will this happen? All these things are actually important. And you can think of it, if you know Agile, it's like a Scrum user story. So you really write this out. James from IT will use this model once a week at 3 p.m. reading data, and he will solve this specific problem. And you might now say, oh my God, this is a bit over the top. And this is very hard fixed. But it's not. It's absolutely okay to change your purpose. In fact, that is the most natural thing. It always happens. So you can change the purpose, but you need to realize that it's a change of purpose, and you need to communicate it with your client. So we are in a workshop, so let's actually work together. I would love to do this interactively on a stage with you guys now, but we are remote. So I count on you actually working together with me. We will do a little purpose statement. I want you to think about your current or upcoming simulation model. And I want you to write down 3 sentences of the actual problem that you're solving, the actual model purpose. What is it there for? You'll have 1 minute, and we'll do it together. I will do it from my end as well. So I'll give you a couple of seconds now, start writing it down, and then we'll do a purpose together with one of the models here on my end. Okay, I hope you've got something written down. Let me introduce you to the Wealth Gap Challenge. There is actually a talk by Goldward Research Labs. It's a talk after this one, the talk after the next after this one. Go check it out. It's a super cool little model that we built together that had a very specific purpose. So when we got started on this tool, I talked to Alan, the boss of the CEO of Goldward Research Labs, and he said, look, there is this weird thing going on. If you have 100 people in a room, everybody has $100, and you make them trade regularly with each other, and it's a completely fair trade. So you've got a 50% chance of winning, 50% chance of losing. If you win, you get some money from your opponent. If you lose, it's vice versa. You give some of your money to the opponent. That sounds completely fair, but what happens is that you create a huge wealth gap, i.e. you will have, after a couple of hours, you will have a Jeff Bezos in the room. You will have people that will get extremely rich and lots of people that will be very poor. So I talked to Alan about this and said, that's interesting. So he wanted to tell this story. And we can have a look at this. Let me make this bigger. So we built this model together. You see 100 people, and you'll see them trading, and the vertical bar is the wealth of the individuals. And you see over time that lots of people get poor, and some people get extremely rich, and you have to zoom out to actually gauge that. And as I said, there will be a talk that goes into a lot more detail with this. So it's a really fun little tool. But now let's focus on the purpose. Because I was talking to Alan and said, okay, that is an interesting story. What is the purpose of this model? Well, it's to tell that story, he said. And I said, okay, but to whom do we tell this story? And Alan said, well, I want to tell to potential clients and at workshops. And that already informs me how to build this model. And I asked, how much prior knowledge will these people have? He said, well, it needs to be very intuitive. So, so it needs to be intuitive. It needs to be telling itself, essentially, even without Alan. And I probed further, when will you be at conferences? How long will you have time to tell this story? All these kind of things. Came up with a purpose statement that was 3 sentences long. We need an intuitive, self-guiding model teaching academics and interested business people how the wealth gap occurs, even in perfect fair trading. And there were 2 or 3 more sentences. That doesn't matter here. What does matter is that even that can be condensed further. The key purpose of this model was to teach us one insight. Even in perfect trading, people will get super rich and lots of people will be poor. So it's all about extracting that purpose, either from your client, if you have somebody like Alan who has got a vision, or from yourself if you're building an academic model, or from your stakeholders. So practical takeaway of purpose is it should be the very first thing that comes into your mind when you start a project. It's the first thing that you need to take down. It's the last thing that you talk about when you hand over a model. It should be all the way in the middle, always. At least weekly, you need to ask yourself, did our purpose change? Did what I was doing this week actually advance us to the model purpose, or do we have a different purpose now? Both is fine, but you need to be on top of it. You can really push it down the throat of your stakeholders and yourself. You can't think about purpose enough. And if your client asks, can we do X? The first thing that you need to think internally is, does it advance us towards our purpose, or does it change our purpose? And we'll see in the other topics why this is so important. You might say, boring, that's just talk, whatever, soft skills, I don't really care. But you will run into a lot of trouble if you don't do that. Okay, that was the first topic I wanted to talk about. Now, we've got our purpose down. Everybody's happy. Everybody knows what's supposed to happen. Now, the next question is, how do you actually build your model? We'll talk about approaching model building. It's like a philosophy that you should follow. So this model that you see here is an aluminum plant model that I built for a client. Huge aluminum plant. The purpose, we'll always get back to that, the purpose here was to predict the detailed impact of investing and buying new machines or investing into storage. What will happen? Will it pay off? Will we have an ROI or not? Big effort, 6-month project, thousands of man hours, several people working on this model. But let me show you how I started out after we discussed the purpose. So I literally did what you see on the screen now for this very, very big model. I opened AnyLogic, I clicked File, New Model. I thought, okay, we need to model an aluminum plant. So my first thought was machines, things flowing through that lends itself well to the process modeling library. So all I did was drag in a source that will create stuff coming into the factory, a queue that is some storage, a delay that is the actual processing, and a sink that is stuff that goes out of the facility. That was all. That was my very first model of this very huge aluminum plant. So how should you build your models? Well, if you think about it, with this very simple start, you should start as simple as possible. It cannot possibly get any simpler than this in AnyLogic. So that's always a good start. But if you think about it, this is basically the entire system already. I've got deliveries on the left-hand side. I've got the plant is sort of a boundary, things happening inside the plant, and then stuff going out on the right-hand side. So this is where AnyLogic really, really shines, because it gives you these building blocks, and you can build something very quickly, just drag and drop, and you already got a system. Now, what I promise my clients, and you can do that as well, no matter your skill level, is to have the entire system that we are interested in modeled in 3 to 5 days. So by the end of the first week of any project, I promise my clients we'll have the entire thing modeled. It doesn't matter if it's Amazon's global supply chain of everything, or if it is a local crossroad with pedestrians and cars in some little town somewhere. It absolutely does not matter. We'll have the entire thing after a week. And obviously, I don't say it like that to the client. I do say we have the entire thing after a week, but extremely simplified, of course. So not as crassly simplified as this, because this was after 5 minutes. After 5 days, you should be able to have a little bit more features, but everything is extremely simplified. But we have the structure in place. We'll talk about structure. We have inputs, we have outputs, and we have KPIs. The thing is running. We can start doing things. And this is what I call phase 1 of your modeling approach. It's always about 1 week. Unless your entire project is just a week, then it should be a day, but it's very short. So what is phase 2 then? Once you've got this down, phase 2 is even simpler in a sense, because with phase 2, you take your model and then you add a feature. You've got a long list of things that you want to do anyway. Your client has got a lot of things they want to add. So we add a feature. We test that feature, obviously. Make sure everything is still working, everybody's still happy, model is behaving, and we will go into depth of testing in a future masterclass. And then the next thing is simple. You ask yourself, are we done with our purpose? Which means, have we finished? Typically not, so not yet. So you just keep looping, adding features. But if you have fulfilled the purpose of the model, it's time to go flying or whatever you like doing. So this is phase 2. There is really not much else out there. to be done to develop a successful model. With each feature you check, are we on track towards our purpose, or do we need to change the purpose? And then you follow this little loop. But let's get practical. Let me show you another model. I built this last year together with a company called Yogeo, a startup from Silicon Valley. Let me share the screen. And of course, it's a Corona model. So I apologize for dragging that topic in here again. They came to me and said, Ben, with people going back into workplaces, we need to be able to tell companies what will the impact of people wearing masks, people come to the workplace sick, but not knowing it, obviously, what can we do to improve the workplace? So we sat down, developed the purpose of the model, which was to have a sort of a virtual demo model for clients where we show them, look, we've got this fake facility here. We've got people coming into work. People have this social distancing radius. You might have sick people coming in. I think, yeah, there's a Corona guy here who might or might not infect other people. And then you can start playing with options. People wearing masks, putting in all sorts of assumptions of how likely it is to infect other people. I can make it big so you can see it. It looks quite nice. Obviously, part of the purpose was also to make it look nice. Now, that was all nice and well. I built this, took me not too long. And then Yogeo guys came back to me and said, cool. Now, when we take this to clients, they obviously will want to see their own facility. Can you do that as well? Can you make it so generic that it shows any kind of facility? And obviously, that is that's a challenge. That's a danger that you always have, that people say, this is so cool, can we use it for other things as well? But that's okay. But let's go back to the point of approaching this entire model. How did we want to build it? Well, when I first started out, I thought to myself, what is, again, the simple, most possible model that we can build here? So we can do that together again. Go back to AnyLogic, delete this, and think about, okay, what's the simple, most possible model to have, a Corona facility model? Okay, we need a pedestrian library set up because people are walking past each other, and we need this spatial component. So let me just draw some fake office, couple of walls. We need people to arrive at the office. So I use a target line. We need people to walk to their rooms because that was the vision of everything. And then we need a fake office for people to stay there. So step one, some fake geometry. Step two, we need people. So let's create a couple of people at our first target line, which is the office entry. Let them move to the other target line, which is where the office sits, and then let them wait there in that node. So this is not about learning how to use these libraries. This is about learning the approach that I'm following. What's the simple, most possible model I can build? And this is the simple, most possible model. People will arrive here, and they will go there and stay there. But let's go one step further, because this is about social interactions. So what we need is people to have this safety radius thingy. So we can't use the default pedestrians. We need to create our own pedestrians. My pet, give them some animation. Make sure they're actually sort of flagged as pedestrians. And then in the process model, say, please don't create just agents, but create my pedestrians. And now in my pedestrians, I can actually play with a radius. I can literally drag in a little oval here, size it such that it's a meter roughly in radius. So, you can see why AnyLogic is so cool, even or especially for the early stages, because this is all very simple drag and drop stuff. And then the next step is, let me actually open a prepared model, otherwise I'll be writing code here for a little bit too long. The next step is, so this is exactly the model that I've just built, except that I want my pedestrians now to check regularly every second, am I too close to some neighbor? So it's literally looping through all other pedestrians in the model, making sure it's not yourself that you're checking against. And then if you are closer than 1 meter, what we do is we change the fill color of this thing. And I can run this, but I think I need to share the screen separately so you can actually see it. And there we are. So this is the model running now. Let's make it bigger. So you see little pedestrians following their target and noticing, oh, we are too close to each other. Other people are noticing, oh, bloody hell, we are too close to each other. Don't get bogged down on the technicalities here. Focus on the approach, which is, what is this the simple most possible model that we can build? And that is the simple most possible model. So this, doesn't take too long, even if you're a beginner and need to figure out those technical things. And from then on, it's phase 2. This is basically phase 1. Maybe add a couple of KPIs as well. And then it is just iterating, adding features until you arrive at that full-fledged model that fulfills the entire purpose. So takeaway on approaching modeling is phase 1, start extremely simple. Give yourself a week or maybe just a day if it's a short project to have everything ready. Spend the entire system as quickly as possible with care. And then start phase 2, which is just adding features, test, repeat, adding features, test, repeat, nudging yourself closer and closer towards your purpose. And again, if there are any questions, just pop them into the chat and I can answer them now or later on. We'll see. So we've got our modeling approach in place, but I keep telling you, in phase 1, have that entire model ready, which is a big challenge because you need to start thinking ahead right from the start. And the thinking ahead is the thought about how should I structure my model? And this is our next topic, incidentally. How should you structure your model well right from the start and throughout the project so you don't run into too much trouble and too much refactoring? So in this part, we'll talk about 3 things, 3 constructs. We'll talk about hierarchy in models. That's an object-oriented concept, inheritance as well. And at the end, about something that you will have to do, and we will focus on not having it to do too often, which is refactoring. So story time again. Let's go back to that little COVID model. I already started the story where I said, the purpose was to have a demo model. And then Sri from Yogeo came to me and said, this looks so cool, Ben. But if we take this to actual clients to demo, they will want to see their own facilities. So Sri was like, could we make it generic so we can actually reuse it for anything? And this was a 5-day project, I think, and this was about 2 days in where I had this ready, not quite as polished, but ready enough. So it was still a little bit of time, and it's like, okay, but this is a slightly different purpose to the model now. You want a generic demonstrator, not a demonstrator, but a generic one that can be reused for several demos. We still had enough time, so I said, okay, let's go for it. It was a nice challenge. Let's go away from hard coding things to a more generic way of doing things. And one of the ways that I did that was to employ hierarchy to the fullest. So this is a masterclass, so I'll not go into too much details about agent embedding. If you build a model like this about some city or something, you'll probably have a people population embedded in main and a car population embedded in main. And if the purpose of the model is to focus on car KPIs or car performance, you'll likely split this up further and have engines embedded in cars, or wheels embedded in cars, or doors, or whatever. So this is the foundation of object-oriented programming, and AnyLogic is great at that kind of stuff. But you need to make use of it well. The advantage of doing this and embedding agents into each other and building a solid structure is that it's very easy to scale your model. So if you are in phase one, you want your entire model done, or the entire scale of the model, the entire stretch of the model done, but everything super simplified. So there was a question, so I got a little confused. But everything's super simplified. But if you have this hierarchy structure in place, later on you can easily fill things out. So it's all there in place, you fill it out later. Also, it's really cool for scaling. If you just build a model of one road traffic, it's easy to scale up to several road traffics, intersections, or the entire city with a hierarchy like that. It's also cool for data-driven modeling. I did a workshop on that a while ago where the agents actually create themselves. There's no drag and drop or anything. It's all driven by some input data. So check that out. That's on the AnyLogic website as well. And also what we'll see is this breaks up huge flowcharts. Now, absolute beginners in AnyLogic typically just drag and drop stuff onto main. They have huge, big, fat flowcharts, and things get out of control very quickly. Advanced users understand agent types and start embedding agent populations on main, like car and people here. But they tend to build more and more agent types and all put them on the main and not employ this hierarchy thing. But the advantage here is that you can easily break up those flows. So you just leave agent types empty at the start. We'll see that. So let's go into this facility model, into the actual facility model. Make this bigger, bring it up. There was a question in the meantime from one person asking if I could go deeper into the testing side of things. But I'll do this in a separate masterclass. So we'll have a separate masterclass solely focused on testing. So we won't go into this today. Okay, so this is the that Corona model. And what I did now, instead of just drawing all the facilities, I actually created agent types that represent facilities. So I still have, you still need to draw the physical side of things, but that is super easy. Anybody could do this. Even the Yogeo guys could do this. I don't have to be paid for that. So instead, what you do is I created a space agent. And I basically said, you just give it the desk areas and the actual space where it sits. You draw that yourself. And then inside the space agent type, I have a little flowchart. People entering the space will get here, and they'll be sent directly to yet another embedded agent type, the desk. And if you look at the desk, there's a more advanced flowchart here of people arriving at the desk, moving to their desk, doing some work, and then going to a next task. So you can see two things here. It's breaking up flowcharts across different agent types, which is extremely useful with these enter and exit blocks. But also you see spaceholder agents. This spaceholder agent is really not doing much. It's just sending agents from entering the space to actually moving to a desk, and the real functionality happens later on. Same thing with a toilet agent. We had to do those as well. People arrive at the toilet, they go to the toilet, and they do their business for a P duration. I just noted this the other day. That wasn't intentional at the time. So this is basically how you should build your model. You think right at phase one, how should I structure this whole thing so I can fulfill the purpose and have everything in there, even if it's empty or very, very bare bones at the start. Now, with object-oriented programming, what you often hear in terms of promising is you'll have this neat, beautiful structure, but what actually happens is it gets messy quite quickly, and that is true even with OOP experts. So just make sure you keep things clean, keep the structure clean, keep it related to reality, and avoid things like God agents that have access to everything. We'll talk about that in a bit. Let's jump to the next concept, inheritance. Now, again, this is a masterclass, so I won't talk about the basics of inheritance. I want to talk about some advice for using it well. But just to recap, inheritance means that if you have different agent types like programmers, dancers, and singers in your model, they might have things in common, like a name parameter, or some functions in common, like eating or breathing or whatever. But they also have different stuff. So what typically happens with normal advanced users or beginners is they create these agent types, and programmer gets a parameter name, dancer gets a parameter name, singer gets a parameter name. But then you start thinking, well, I don't want to duplicate this stuff. So instead, what you do is you create a parent class, person, and move all the things that they have in common there, and let the child agent classes or agent types inherit. So let's see how that works, and let me give you some more advanced advice on how to use this well. Go into AnyLogic again. And I prepared a little model here that is similar to the screen I've just shown. So on main, we have a population of dancer agents. We have a population of programmer agents embedded. Our dancers can dance. Our programmers can program, and they even have a skill level. But there is no overlap anymore because both these agent types in the properties under advanced now extend another agent type, meaning they inherit from that. And I created that agent type called person_parent. So this is standard inheritance stuff that you do in AnyLogic, but how should you actually be doing it? First of all, you should make sure that your parent class is what's called an abstract class in object-oriented programming, meaning you should not create a person parent. You should only ever create programmers and dancers. Keep this abstract. Do not instantiate it. Now, this is easy said, but it could happen accidentally, especially if you have several people working on your model. So there's a little trick to make sure it doesn't happen, which is on startup of this class, you can check, did you actually just instantiate this? You check, is the class name equal to person_parent? And if so, you just throw an error to the user, say, do not instantiate this directly. There are other ways to do this, but this is the sort of a quick way to make sure this never gets instantiated. The second thing is the naming. I make sure in my agent type name to remind myself this is a parent agent type. So either put it at the end, might even be better to put it at the start, parent_person, whatever you prefer, but make sure that's there. And then moving parent characteristics, you typically move them to the side somewhere because they shine through in the child agent classes. To be honest, I'm a very clean person. People working together with me on models will testify to that. So I even put little visual clues here that this is parent stuff. So when I then edit things on programmer, I remember, oh yeah, this was from the person-parent class. But that's just me. I'm a very tidy person when it comes to programming. So master advice on inheritance is to flag your agent types as parent, avoid instantiating them as I've shown you, and thirdly, use it with caution. What I always see is people, once they understand the concept, they overdo it because it's a powerful concept and they start inheriting like crazy. And you go all the way in, you have living beings, and then you have humans inheriting from living beings. You have females inheriting from humans, inheriting from living beings, and mushrooms. And you can really, really overdo it. My advice in my models, even the most complex one, there's rarely an agent type that inherits from more than one parent class. Very, very rarely. if ever. And it's absolutely fine to have complex models without any inheritance as well. So use it with caution, use it when it's useful, but you can easily overdo it and things get complex quite quickly. All right, so back to structuring your models well. We've learned that you should put the structure in place early on. So think ahead. We've learned it's better to overdo it with agents embedding into each other. It's better to underdo it with inheritance, but still you will run into an issue. And that is refactoring. So what I'm saying is you should accept refactoring and avoid it as much as possible, but it will happen. And it happens when your structure that you've set out is not applicable anymore. So for example, a client came to me and said, Ben, I want you to build a nice little car. I've done that. I've built a beautiful little car. We talked about the purpose is to have a nice little toy car that drives around. So there we are, beautiful. And he said, oh man, that's an amazing car. Can you, add a second passenger? It's like, well, okay. Got a second passenger. It's like, cool. I also need a trailer. I forgot to mention that. It's like, okay, I'll put a little thing at the back so you can add a trailer at your own time because we are nearing the end of the project. We're in a hurry. It's like, yeah, but every car, you always have a bin inside, right? If you need to throw something away. So, okay, we've got a bin now. No problem. And he said, oh, but the most important thing I forgot is this needs to fly as well. Okay, put a wing on it. And you remember we talked about reindeers, right? Okay, so I'll add a little reindeer. And there we go, project time is up. There's your thing. Okay, but obviously this is not very beautiful. So what you should do instead is when the purpose changes and your original structure is not useful anymore and you start adding things on top of it, do not end up like this. Instead, you need to go to your client and say, all right, we need to take time to refactor this. This has gotten out of hand. So instead, you want to build something elegant like this. It shouldn't look like this. It should actually be looking like something like this. So refactoring is a regular exercise. It's often caused by a change in purpose. The client has new ideas, or it wasn't quite clear from the start, and your hard-coded initial structure constructs are not useful anymore. For example, going back to the Corona model, my structure was to have spaces or rooms and toilets and other things all embedded in main. Nice. And I built this generic cool model. Let me show it to you again because I'm quite proud of it. Got the beautiful model. We now had this not hard-coded structure anymore with spaces, and you could build these things in minutes now. And then 3 from you guys said, yeah, but some of our customer facilities have a second floor or any number of floors. So actually, we need this concept of floors as well. It's like, oh boy, okay, so that will be a refactoring that I didn't see coming because, yes, obviously. But typically, you don't think about these things up front. So first of all, I create a manual first floor room, but this structure was not applicable anymore. And we were running into this danger. So didn't want to go there. So the refactoring was then to say, okay, let's give rooms the property of having different floors. And this activity, refactoring, is always open heart surgery because you are deleting hard-coded things that you sort of put on top before, but this will break up other things. And suddenly even this won't work anymore because you've done things. So to refactor it to the final form is often unplugging things, plugging them into different sites. So it is a dangerous activity that you have to do regularly, you have to be good at it, and you have to take it slow and methodical. Don't get scared by it. You need to communicate it to your client, most of all, that it will take time. The model won't be usable for a little bit, but after that, we can develop so much faster because we can have any number of floors now. We can have any number of reindeers now, these kind of things. So take away from structuring, define your structure early on in that phase 1 of approaching your model. It's better to overdo it with embedding things and keep them empty. We'll also see later in collaboration why it's better to do that. Use inheritance, but it's better to use that sparingly. And then expect refactoring. Even if you've built the perfect structure up front, you will need to refactor things. So don't shy away from it. If very good IT companies, when you do an interview with them, one of the questions you should actually be asking is, how much time do you reserve for refactoring? With simulation companies, that's probably not there yet, but in the IT world, this is common practice. Everybody knows about it, and you need to have time for refactoring regularly. It's just a fact of life. Okay, we've got a couple of questions, so let me take those. The parent class and child class put in the same model is, Chunzi is asking that. So yes, they are being put in the same model. It all is part of one model structure. And then another gentleman asked whether design patterns are really, really helpful. Well, let's see. We'll get to that when we talk about the next thing, the final topic of collaboration. So as I said, simulation models get a lot bigger, and people start working together on one simulation model. So people need to collaborate. Now, I've worked with clients where there was no versioning. They didn't like GitHub because it's sort of in the public domain, whatever. They don't have their own private versioning system. So we end up with this horror. And it is such a pain. Obviously, do not go there. Instead, what you should start learning is not SVN. AnyLogic actually at the moment has built-in support for SVN, but SVN is only really useful if you work on a model all alone. Then it's a fair versioning thing, but the industry standard has shifted to Git. Everybody's using Git, so you might as well just go there. And the future versions of AnyLogic 9 will support Git as well, as far as I'm told. But you should be using Git even with AnyLogic 8 models. Again, it's a masterclass. So I'll skip on some of the basics. If you are a lone developer, let me just say, start using GitHub. You have a free account. Even with a free account, you can have private models, so they're not in the public domain. They're your models. Nobody can see them. You should commit every 15 minutes, very frequently. Commit more often than less often is good. And if you want to test something that you're not sure if it's going to work out, you branch off, test your thing, merge it back into master. Now, again, if these terms don't mean anything to you, we will have a masterclass on collaboration where we do these things in detail. But here I want to go one step further. And that is to talk to people who collaborate on models together. Because the main issue, the main problem is that you will run into what's called conflicts. Now, a conflict is when two developers writing code change the same line of code. And then they want to merge it together, and Git wouldn't know, well, who's the right one. In normal coding, when you don't build simulation models, but write any kind of code, that happens from time to time. It's not a big problem. You solve the conflict. The problem with AnyLogic is it happens a lot more often if you're not careful and if you don't follow some basic rules. And this is what I want to talk about. Now, the first thing to understand is, why does it happen so often, these conflicts with AnyLogic, and why is it such a pain to resolve those conflicts? So let's go back to AnyLogic and see. Big again. Let's create a simple new model. And we will just add 2 parameters to that model. We'll have a normal parameter. We'll give it a default value of 12. We have another parameter. We'll give it a default value of 30, something like that. Super simple model, all good. Now, let's say this model is now stored on GitHub, and 2 developers start working on it, doing different things. They agreed what each one of them wants to do. Now, developer 1 decides to delete this parameter. This will cause a problem. And why is that? Because you need to understand, whenever you drag something into AnyLogic, AnyLogic is actually writing Java code for you in the background. So the code for this first parameter is this one. It's creating a parameter. It's creating some methods that return the default value. So it's writing stuff. A little further down, it has also written the code for the second parameter I created, parameter 1, the default value of 30. And that's absolutely fine. But when the first developer now decides, I don't need that parameter, actually, the model is fine without it, the code for that is now deleted. He keeps working, plodding along, then he's a call with the other developer and says, oh, actually, no, bloody hell, we do need this parameter. Let me drag it in. What was the default value? It was 12. OK, we do need it. But if I go into the code now that AnyLogic is written, it's the same code written again, but it has been written now below the code for parameter 1. So it's like a sequential code writing thing. If you delete something, drag it back in, the code appears somewhere else. If these two developers now want to merge their code, you will get a conflict. And it's a pain to resolve these kind of things. And there are a couple of other things that can cause these kind of conflicts that are unique to AnyLogic. The reason for it is that AnyLogic writes code for you, then converts it all in a big fat XML file, and then Git or GitHub reads that XML file and compares it and sees, oh, that used to be here, but now it's down there. That looks different to me. And we have a conflict. So the question is, how can we avoid those things? Well, a couple of things based on what we've learned so far. You need to set up your structure early and fill and refine it later. So have lots of little agent types embedded to each other. That's all fine. Keep them empty. So be generous. Give a generous sprinkle of agent types to your model. No problem. And why is that? We'll see in a second. The other thing is, that's one of the questions that we have, is it's a good idea to follow OOP design principles. So one of them is called SOLID, which is an acronym for a couple of things. But what it means in our way here is that it's a good idea to design your agents to be self-contained and only know about themselves. That's called encapsulation. And then they talk to other agents and exchange messages, but they should all, a car should really just know about itself and what car is and what car does. There shouldn't be a method of inside a car to switch a traffic light or something like that. Also, you should be using Java classes when possible. So, for having agent types, having advanced data types, think about using Java classes instead of agents. So you should use agent types whenever you need agent capability, spatial stuff, temporary stuff, state charts, that kind of stuff. But for advanced data processing, it's better to use Java classes and write pure Java code. And then use interfaces, use inheritance, these OOP things, but sparingly, because now we reap in the rewards of what we've set up for our collaboration. If you work like that, this is how collaboration on GitHub should work. You should have one master branch, that's the black line with commits. And every developer, whenever they start something, an issue or task or feature, they just branch off. They don't develop on master. They branch off, do their little bits, do commit every 15 minutes or something to their branch, and then merge it back into master. Now, merging back into master, that's what's called a pull request, which means you actually ask another developer, hey, at this point, can you have a look at what I've developed on this blue branch? Can you review it for me and make sure everything is fine, and then we merge it back into master. The other concepts that you need to follow is that developers never work on the same agent type. Now it should all fall together. Having lots of different agent types in a solid structure gives you the ability for one developer to work on the car functionality, the other developer works on pedestrian functionality. You will not have conflicts because these things are separate. Even if you drag things in, delete things, what I've shown you previously, you are on one agent type, so no conflicts there. In Goldward Research Labs, where I collaborate a lot with other people, we even take it one step further. We separate UI agent types from functional agent types. So I will have a UI car agent type that is solely responsible for animating my car, and it will take a car agent that is solely responsible for functional stuff. So one person can refine the visuals while another person refines the functional stuff. The more you split out things, the better it is, the easier it is to collaborate. Never work on the same agent type. You need to agree this upfront before creating a new feature. Who works on what? That's what you have daily check-ins for and stuff like that. Then also, let's say we are the green developer here. We we merged off, branched off master, developed a new feature. We are finished here at the end, and we want to start a pull request and ask somebody to review our work. But what we need to do is we need to first update our green branch from master, because some other developer might have already pushed to master, new feature there. So before you even ask for a pull request, it's a courtesy to make sure you update from master and not have any conflicts. Your model still works. And if you follow the advice from previously, your model will still work. So it should be fine. So with these concepts, you will have where conflicts. And in the future masterclass, we'll look into how actually to resolve conflicts. But start with these principles, and conflicts will be really, really rare. All right, so we are nearing the end. We have done a little bit of a tour de force through 4 important concepts. I hope you had fun. I hope you enjoyed my Lego car. I will have a suite now. As I said, we will have more masterclasses coming. We will deep dive into the 4 topics that we've discussed today. We'll deep dive into other topics. Feel free to suggest some topics. But this is really about going deeper and going beyond the usual things. Any feedback, welcome. Message me on the conference platform, send an email there, meet me on LinkedIn. There should be lots of ways to reach out. It's a shame I can't hear or see you, but I hope we see each other next year. We will definitely see each other in 2 hours' time, because there will be another workshop where we talk about how to make the community experience better for all of us. But that's a different thing. So thanks a lot.